So friends, today we'll discuss the amines. So amines in the sense the compound which contain amino functional group as well as alkyl group. So let me discuss about the definition of amine. Amines are the derivative of ammonia in which one or more hydrogen atoms have been replaced by alkyl group. Here we have taken one example, methylamine. CH3 group is there and NH2 group is there. Alkyl group attaches to the amino group, that is called as amines, or amino group attaches to the sp3 hybridized carbon atom, that is also amines, and it is derivative of ammonia in which one hydrogen is replaced by methyl group, that is called as primary amine. It is derivative of ammonia in which two hydrogens has been replaced by the methyl group, that is called as secondary amine, example dimethylamine. And then three hydrogen has been replaced by three alkyl group, that is called as tertiary amine, and example is trimethylamine. So definition is derivative of ammonia in which one or more hydrogen have been replaced by alkyl group. Then we'll see the various properties, physical properties of amine. First, lower amines are liquid in nature. Higher stretch of NH from the amine, it is observed at the 3300 to 3500 cm inverse. Amines are water insoluble because NH bonds, they are not forming hydrogen bonds with the water, but they are soluble in the organic solvents. And H1 NMR shows the peak at in between the 0.5 to 5 chemical shift or delta. Then we have classification for the amine. Primary amine. So what is meant by primary amine? Amine has only one alkyl group directly attached to the nitrogen, that is called as primary amine. Secondary amine means the amine which has two alkyl group directly attaches to the nitrogen, that is called as secondary amine. Then tertiary amine, a amine which has three alkyl group directly attaches to the nitrogen, that is called as tertiary amine. Then we'll see the examples: primary amine methylamine, secondary amine dimethylamine, and tertiary amine is trimethylamine. Then we will see the definition or the basicity of amines. Initially, amines are act as a Lewis base because it donates the lone pair of electron to form new bond with the hydrogen atom. The definition of Lewis base is to donate the lone pair of electron to form pair with the another atom. Here, ammonia acts as a Lewis base. If you are treating amine with the water, it will produce RNH3 plus and OH minus sign, and we will see the equilibrium constant for this. Kb is equal to concentration of product divided by concentration of reactant. RNH3 into OH minus sign divided by RNH2 plus water. So that is equilibrium constant. Then this also we can treat with the water, RNH3 plus water to form H3O and RNH2. And for that also we will draw the equilibrium constant. Concentration of product divided by concentration of reactant, H3O plus or into RNH2 divided by RNH3 plus water. So this is the equilibrium constant. Equilibrium constant we are measuring in the terms of pK value. The more pK value indicates the compound is more basic one, and equilibrium shifted towards the right side, that indicates higher pK value or Kb value indicates the compound is more basic. Example, pK value for amines will be observed at the 10, and pK value for acid will be observed at near about 4. So measurement of amine basicity through the acidity of conjugated, that is it. Equilibrium shifted towards the right, pK value will be greater, and we will have the base. And we will see the basicity or pK value for the various amines. Similarly, plain ammonia which doesn't have alkyl group, the pK value will be 9.3, then methylamine 10.62, then dimethylamine 10.64, triethylamine 10.65, then diethylamine, triethylamine will be observed the pK value for various compounds. And we will see the substituent effect on basicity. There are two factors, one is alkylation factor and another is nature of amine. We will discuss alkylation factor. As the alkyl chain, alkyl group increases, the basicity of amine will be increases. Any factor that increases electron density on the nitrogen atom, that increases basicity. So alkyl group increases electron density on the nitrogen atom. That's why as the alkylation increases, basicity of amine also increases. Example, ammonia is least basic as the alkyl group having more electron density. Hence it will add the electron density on the nitrogen. So alkylated ammonia is strongest. So basicity we will compare in that way. Ammonia is least basic, then it is stronger than ammonia. Primary amine stronger than ammonia. Secondary amine stronger than primary amine, and tertiary amine stronger than secondary amine. Then second factor is nature of amine. Here we have three amine. One is primary amine, second one is amine, and third one is cyanide. So sp3 hybridized carbon atom, which gives maximum electron density to the nitrogen, then the sp2 hybridized carbon atom, then the sp hybridized carbon atom. So sp3 hybridized carbon atom, which adds the electron density on the nitrogen and which is more basic one. Here sp2 hybridized carbon atom gives less electron density to the nitrogen, hence it is weak basic than the amine and strong basic than the cyanide. Cyanide contains sp3 hybridized carbon atom which has less electron density, also it gives less electron density to the nitrogen, means cyanides are least basic. Then we'll see the preparation methods for the amine. There are 11 methods we will discuss here for the preparation of amine. First one, reaction of alkyl halide with the ammonia. Second, Gabriel phthalimide method. Third, reduction of nitroalkane. Fourth, reduction of nitriles. Fifth, reduction of oxime. Reduction of isonitriles. Reduction of amides. Reductive amination of aldehyde ketone. Reduction of alkyl azide. Hofmann degradation of amide, and reduction of acyl azide. You are seeing the various method here. We are applying only one method, that is reduction. And to whom we are going to reduce means those compound which has the nitrogen source, and from that nitrogen source we are synthesizing the amine. How it will be, we will see. First method, reaction of alkyl halide with the ammonia to form amine. So this is ethyl bromide we have taken. We have treated with the ammonia, and solvent is ethanol. So NH2H and Br. H from ammonia, Br from this will be liberated as HBr, and NH2 group migrated towards CH2 to form ethylamine. So ethyl bromide treated with the ammonia in presence of ethanol to form ethylamine. And second method, Gabriel phthalimide method. For that we have taken starting metal phthalimide. We have treated with the KOH. So K will be migrated towards this H and OH liberated as water molecule, and this potassium phthalimic compound will be produced. This we are treating with the alkyl halide, that is ethyl chloride. Here potassium and chlorine will be liberated as KCl, and CH2 will be migrated towards this to form this N-ethyl phthalimide. Then this N-ethyl phthalimide treated with the potassium hydroxide. So this OK will be migrated to this, and another OK will be migrated to this to form potassium phthalate, and reduction to hydrogen migrated towards the nitrogen to form ethylamine. That is the Gabriel phthalimide method for the synthesis of ethylamine. Next method, reduction of nitroalkane. We are applying reduction means we are treating with the reducing agent. So nitroalkane treated with platinum, and we are reducing this nitroalkane to form ethylamine. Here oxygen will be removed and hydrogen will be added. We are treating nitroethane with the hydrogen in presence of platinum to form ethylamine. Two molecules of water molecule will be liberated. Two hydrogen will be added. Two oxygen will be removed. So 3 molecules of hydrogen required. The next fourth method, reduction of nitrile. Here the cyanide group we are taking. Nitrile means cyanide. We are treating with the hydrogen. 2 hydrogen will be added to this, and 2 hydrogen will be added to this to form N-propylamine, and reducing agent is platinum. And fifth, reduction of oximes. So this oxime NOH, so finally compound we should have NOH, that is called as oxime. Same method we are applying reduction in presence of platinum. OH and H will be liberated as water, and two hydrogen from this attaches to this, and one hydrogen from out of four hydrogen will be migrated towards, and it will produce N-propyl amine. That is a reduction of oximes. Sixth method, reduction of isonitrile, that is isocyanates we are calling. Secondary amine may be obtained by reduction of isonitrile. Example, ethyl isocyanates. We are treating with the hydrogen in presence of platinum, and we are getting reduction 3 hydrogen and 1 hydrogen here. This total 4 hydrogen will be added to form secondary amine, that is N-methyl ethanamine. Next, reduction of amide. Primary amines can be obtained by reduction of simple amides with the help of lithium aluminum hydride. So this is propionamide. We are treating with the 4 molecules of hydrogen or twice H2. Then undergoes reduction in presence of ALH4 means lithium aluminum hydride. So this hydrogen added to this, oxygen removed, and we are getting water molecule. So 2 hydrogen for this and 2 hydrogen for abstraction. This means 4 molecule of hydrogen will be required, means twice H2 will be required to reduce and to produce propylamine. Next, reductive amination of aldehyde and ketone. We have taken one example, propionaldehyde treated with the ammonia and hydrogen. So this is going to reduce and NH2 is going to attach to form propylamine. Then reduction of alkyl halide. So we produce alkyl halides, alkyl azides. We are treating alkyl halide with the sodium. We are treating propionaldehyde with the sodium azide and to form alkyl hazide. Here propenyl halide. Propenyl halide, not propionaldehyde. Propenyl halide treated with the sodium azide in presence of ethanol to form propenyl azide or propyl azide, and this is going to treated with the reducing agent lithium aluminum hydride, and it will produce propylamine, and it will reduces to form nitrogen gas. Then Hofmann degradation of amides. Conversion of amides into amide into amines with the help of sodium hypohalides is known as Hofmann degradation. Then we have taken one example, propionamide. We are treating with the bromine in presence of sodium hydroxide to form ethylamine. So this group will be removed, carbonyl group will be removed, and ethylamine will be produced. Then we will see the mechanism. Initially NaOH is going to ionize into Na plus and OH minus ion. Then we have one example, propionamide. So hydrogen will be abstracted by this OH to form water, and this will be produced. Nitrogen should have negative charge, and we will treat it with the bromine. Bromine migrated towards this to form this compound, and then again OH group tries to migrate this hydrogen to form this compound, and sodium again will abstract the bromine from this to form isonitrine. Nitrogen have negative charge, hence for the negative charge alkyl CS3CH2 group tries to migrate towards this to form isocyanate, and isocyanate again undergoes hydrolysis, breaking up this bond. So oxygen goes to there, into hydrogen goes to the nitrogen to form ethylamine. So this is the degradation or Hofmann degradation of amides. At Curtis rearrangement reaction, this reaction converts azyl halide to primary amine. So propanol chloride we are treating with the sodium azide. It will produce acyl azide, and acyl azide undergoes hydrolysis in presence of heat. So this will be carbonyl group will be removed as CO2, nitro group will be removed as N2, and ethylamine is going to produce. That is Curtis rearrangement, and mechanism same as your Hofmann degradation reaction, removal of the carbonyl group. Then we will see the reactions of amines. First one is salt formation, second reaction with the alkyl halide, reaction with acid chloride, reaction with nitrous acid, reaction with benzenesulfonyl chloride, and carbylamines. And we'll see the salt formation. This is the amine. We are treating with the HCl. So H we migrated towards this, Cl migrated towards this to form ethyl ammonium chloride. That is the salt formation. Second reaction with alkyl halide, ethyl amine treated with the methyl chloride. So CS3 attaches to this to form dimethylamine, and again this methyl ethanamine treated with the methyl chloride to form trimethyl or N-dimethyl ethanamine. This is a tertiary amine, and this tertiary amine again treated with methyl chloride to form quaternary ammonium salt. Simply formation of primary amine converted into the secondary amine, and secondary amine converted into tertiary amine, and tertiary amine converted into the quaternary amine, simply with the help of alkylation, and alkylation done with the help of alkyl chloride. Then third method, reaction with acid chloride. Primary amines react with acid chloride, that is acetyl chloride. Cl from this and H from the amine will be liberated as HCl, and it will produce amide, NHCOCS3. That is ethylamine treated with acetyl chloride to form N-ethyl acetamide. And fourth method, reaction with the nitrous acid. Primary amine react with the nitrous acid to form diazonium salt, and diazonium salt hydrolyzes to form alcohol. So propylamine we are treating with the sodium nitrate and HCl at 0 degrees centigrade, and this will to form diazonium salt. Diazonium salt again removes the nitrogen and chlorine to form positively charged carbocation. This positively charged carbocation undergoes hydrolysis to form propane 2-Al or 2-propanol. Then we will see the reaction with benzenesulfonyl chloride. Primary amine treated with the benzenesulfonyl chloride to form N-alkyl benzene sulfonamide. Cl and H from this will be removed as HCl, and to form isopropyl benzene sulfonamide. So this is the compound, and this test we can use for the identification of amines also. Primary amine gives yellow PPT, secondary amine and yellow PPT with which is soluble in the NaOH. Secondary amine gives PPT but insoluble in NaOH, and tertiary amine gives PPT which is soluble in the HCl. So these are the identification test for the amines. And sixth method, Carbylamine reaction, when the primary amine treated with the chloroform and KOH to form methyl isocyanide and KCl and water molecule. This test also we can use for the identification of amines. And we will see the qualitative test for amines. First test is salt test. 0.1 gram of sample, 5 mol of 10% HCl. If you are getting clear solution, indicates the amine is present. Then carbylamine test, we have discussed in this reaction. Primary amine treated with chloroform KOH to form methyl isocyanate. 0.1 gram sample, 2 gram chloroform, 2 ml alcoholic KOH. False smell of isocyanate indicates primary aliphatic or aromatic amine. The next is diazotization test. 0.1 gram of sample, 10 drops of concentrated HCl, boil and cool in ice water, 4 to 5 drops of sodium nitrite and water to form 2-naphthol in NaOH. If you are getting red solid, secondary amine, red color, tertiary amine, orange PPT, primary amine. We have discussed this as a diazotization reaction here. Amine treated with sodium nitrate and HCl at 0 degrees centigrade to form diazonium salt. And diazonium salt, primary amine having yellow PPT, secondary amine forming red color, tertiary amine having red PPT. So this is the conformation. Then Hinsberg test. 0.1 gram of sample treated with the benzenesulfonyl chloride and 5 to 10 drops of ice cold water. If you are getting red pipette, yellow pipette dissolves in NaOH, primary amine. Pipette insoluble in 10% or 5% NaOH, secondary amine, and pipette soluble in 10% HCl, that indicates tertiary amine. So these are the criteria for Hinz-Boyce test. Hinz-Boyce test we have discussed in the reaction also here. Amine treated with sulfonyl chloride, benzene sulfonyl chloride to form sulfonamide. Primary amine gives yellow pipette which dissolves in NaOH. Secondary amine gives pipette soluble in NaOH, and tertiary amine gives pipette soluble in 10% HCl. So this is the qualitative test for the amines. Then we'll see the structure and uses for amines. First compound is ethylene diamine. Ethylene diamine, one amine, ethylene diamine. Ethanolamine, 3 ethanol group attaches to the nitrogen. Ethanolamine, and ethanolamine. This is the structure of ethanolamine. And amphetamine, benzene, CH2, CH, NH2 and CH3. This is the amphetamine. We'll see the uses. Ethylene diamine used in the manufacturing of fuel additive, bleach activators, chelating agent, corrosion inhibitors. Ethanolamine, it is used as feedstock in the production of detergent, emulsifier, polishes, corrosion inhibitor and chemical intermediate. Amphetamine, it is nerve stimulant. It also treats the attention deficit hyperactivity disorder. Nerve stimulant means excitation of the neuron. It treats the attention deficit hyperactivity disorder, means the person which are not having attention on the particular teacher, they are having in another mode. So that type of disorder will be treated by the amphetamine. So thank you very much for listening and watching my video. Thank you very much.